Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the WinCC Explorer version 7.5 connect with the PLC S7-300. That topic today we will discuss about how to use the analog input and output module of the PLC CPU 314C 2PN/DP. The concept of this video, I will show and share about how to use some analog signal connect with the SCADA WinCC Explorer. Example, we can set point the frequency of the motor to the VFD or to the some electrical devices, and we can show the feedback from the VFD or feedback of the motors frequency. We can show current of motor, or we can show the status of the temperature of the motor. Okay, so all this include the analog input and output. Basically, if we would like to set the frequency of the motor to the VFD, so we will use the analog output, right? So example, I set 25 Hz. So I will use the analog output connect from the PLC to the VFD, okay? And if I would like to show the frequency of the motor, or current of the motor, or temperature of the motors, I will use the analog input connect from the sensor or VFD to the PLC module. Okay, and in this section I will show and share about how to use the scale analog input and unscale analog output, and then we will connect to the WinCC Explorer. Okay, so in this section I will use two software. The first one is SIMATIC Manager, and the second one is WinCC Explorer. Okay, so to do this job we need to know about how to wiring the connection of the PLC, right? So the wiring is very important. If we don't know about how to wiring, we cannot do the project also. Okay, so I will show how to wiring. Okay, here is the library of my tool. So I don't have VFD or some sensor, so I have only a multimeter for measure the analog output, and I have RTD calibrator for send the temperature of the motor. Yeah, this one, just example. And I have the current loop source. Yes, I solve with the milliamp to the analog input to show the frequency of the motor and current of the motor. Okay, so here is just example about overall of the terminal of this module. So in this part we don't discuss because we already learned in the previous video. So we will discuss only this module. Yes, so if we purchase the CPU 314C 2PN/DP, we will got the 24 digital input, 24 bits, 16 bit of digital output, and we will got the 5 analog input 5 channel, and we will also got the analog output module 2 channel. Okay, so it built in this CPU. 314C 2PN/DP, and we have also Profinet port 2 ports and Profibus 1 port. Okay, so we will discuss about how to use the analog. So we focus about this module, this part. So here is the detailed drawing. So totally I have connected of my RTD calibrator, current source loop, and multimeter connect to the terminal. Follow this step. So if we would like to use the RTD, we can use the terminal number 14 and 15. Yes, here. And this one is the analog input channel number 1, analog input channel number 2, analog input channel number 3, analog output channel analog input channel number 4, and the last one of analog input channel number 5 is RTD. So here on the hardware configuration, we will learn about how to configure for current or volt. Yes, so we can select among these terminal. If we would like to use current, we can use the terminal number 4, it is minus, connect with the terminal number 3, it is current. Example 4 to 20 milliamp or 0 to 20 milliamp. And if we would like to use volt, example 0 to 10 volt DC, we can use terminal number 4 with terminal number 2. Okay. So for channel number 2, number 3, and number 4, it is the same concept, except channel number 5, it is RTD only, so we cannot select volt or M. Yes. And for analog output, we have totally 2 channels. The first one is PQW 800. If we select and connect the terminal 20 with the terminal 17, we will got M from the analog output. Example, we set point the frequency. So if the VFD or some electrical devices use current or volt, we can set from here, and then we can connect from this terminal to the device. Okay. So if we would like to use volt output, we can use terminal number 20 and terminal number 16. Okay. And for channel number 2, PQW 802, also the same. Okay. So I hope everyone will got this drawing. Yes, because I already detailed. So it's very important for the wiring. Yes, that's why I just draft the drawing to explain to everyone. Okay, good. So now let's go to our software, WinCC Explorer and SIMATIC Manager, and I will detail about how to select the configuration volt M of analog input and output. Okay, so let's go. Okay, so right now I will use two software. The first one is SIMATIC Manager and the second one is WinCC Explorer. Okay, right now I use 5.6, version 5.6 of SIMATIC Manager, and I will create a new folder. WinCC Explorer connect with PLC S7-300. Okay, and we focus about how to use the analog input and output only. Okay, And then we can go to our software SIMATIC Manager and then create a new project. Yes, can choose File, New, and then we can put the project name, example WinCC Explorer Analog. Okay, and then we can browse to find the folder that we already created on desktop. Yes, I will choose the folder here. So first we need to create the hardware configuration. Yeah, the same as my slide that I already show here. Yes, so we need to choose the CPU 314C 2PN/DP. Yes, okay, so we will create the SIMATIC 300 station. Example analog signal. Double click again, go to the hardware configuration. Yes, so here we can use insert the rack. Yes, drag and drop the rack 300 to the project. Yes, and then we can go to CPU 300 and then find the CPU 314C 2PN/DP. Okay, here, and this is a part number, and here we can select the last version 3.3. Yeah, drag and drop the version 3.3 to the rail, and then we will got this one. Yes, IP address 192.168.0.1. okay, so please remember this IP address because we need to use with the WinCC Explorer. Okay, I will show in the next step. So let's click OK first. We will got here, we will got DI, yeah, digital input 24 bits, digital output 16 bits, analog input 5 channel, and analog output 2 channels. Okay, so now we will go to configuration of the analog input and output, right? Because we focus our topic. Yes, so to configure the analog input and output, let's go to double click and go to input. Yes, and here is the address. It will start from PIW 800 until PIW 809, right? The same as my slide that I already show here. Yes, it will start from PIW 800 until PIW 809. Okay, and for analog output also start from PQW 800 until PQW 803. Okay, totally 2 channel. So we will go to input tabs, and then here, let's see here, it is the degree Celsius. Yeah, because it related with the standard. Yes, resistance or standard RTD here. It is channel number 5, right? Here. So I will select with the input type the current because I have only current source and RTD, right? And here also I will use the analog output for current also for 220 milliamp. Yes, so I will select current. Yes, the default is volt, so if we would like to use volt, we can select here to use volt 0 to 10 volt or plus minus 10 volt. Okay, so it depends on our electrical devices. If input is volt, we can select volt. If input current, we can select amp. Okay, so right now I will select current, and then I will use standard. Yes, I will use 4 to 20 milliamp. Yes. Okay, channel number 2, I will select the same. It's very important for hardware configuration. Yes, for the basic. If we configure incorrect, we cannot use with our device. Okay, so I will go slowly for easy to understand. Yes, so here also, and here I will use RTD 2L standard. Yeah, standard PT100. Yes, because I already connect here. Yeah, this one RTD calibrator for test, and here terminal 14 and 15. Yes. Okay, for analog output, I also use current. Okay. Okay, and then save and compile the project. And then we need to download. Yes. So please remember here, it will start from 800. Yes. And we can also edit. Yeah, edit the symbol. Example PIW 100. It is the current of the motor or something. We can also remark. Yes. So right click and then choose the edit symbol. Let's see here. We can write the symbol. Example the bit number 1. Sorry, the channel number 1 address 800 PIW 800. So I will remark as feedback or frequency feedback, frequency or feedback speed motor. Yeah, I will use speed motor, and the data is integer, and we can comment as speed feedback of speed motor. Yes. And for channel number 2 example, I will use feedback current of motor, right? Feedback current motor, and the data type is integer also. Yes, feedback current motor from VFD. Okay, on from VFD. Okay, and for channel number 2 sorry, channel number 4, number 5, channel number 3, number 4, I will spare. Yes, so I'm no need to remark something, or we can remark as spare, integer, spare channel, integer also. And we can remark here no use. And for PIW 808, right? So I will use the temperature motor, and here is the integer also, yes. And here we can remark as measure temperature of motor, yes. And here we have set point frequency or set point speed to VFD, right? So I will use set value speed motor, okay. And the data is integer also. This one should be word, right? So word. So set point speed to VFD, speed motor to VFD, yes. And this one I will remark as spare, yes. AQ spare. The data is word also, and I will remark as no use, okay. And then we can apply, yes, and save, compile again. And we need to download the hardware configuration to the PLC, right? So here I will connect the LAN cable from the PLC to my PC. Yes, so let's go to network adapter. Okay, this one not yet connect, right? So I will connect the LAN cable from PLC to the PC. Okay. So wait a moment for connect. So right now it connected, yes. Okay. Basically we can put the manual of IP address of our computer, yes. Because here is the IP address of PLC 192.168.0.1. So example, I can select 192.168.0. something, but not .1. Example dot 253, yes. Yes. And then we can download the hardware configuration. To download the hardware configuration, let's click here and then click download to module. Click OK and wait a moment for scanning the module. It will detect, yes, automatically detect the CPU if the LAN cable was connected from our PC to the PLC, yes, the Profinet port. So wait a moment. Okay, so right now it detects one CPU of PLC 192.168.0.1, and then we can click OK. OK again to confirm. During this time, it will stop the CPU. Yes. So click OK to confirm and stop the CPU, and then restart the CPU again. Yes. Finish download it. Save again to confirm. Yes. And then now we need to use the scale, right? If we would like to show like this, yes, we need to use the scale. Example, current of motor or speed of motor, yes. So let's go here, go to blocks, and then go to OB1, open OB1, and I will use the ladder. Okay. So the first one, we need to show the feedback speed of motor, right? Okay, so let's go to remark here. I will go slowly because we need to use the library. Yes, if we install the SIMATIC Manager, we will got the library. Yes, automatically got the library. Yes. So here is the feedback speed of motor, right? Example, rank from 0 to 100 and 1500 RPM. Yes. So let's go to library tab here. Okay. And then go to the standard library, yeah, to scale, because we need to scale the raw value from here. Example, if we are online, yes, I will online. And then if we type PIW 800, PIW 802, PIW 804, PIW 806, PIW 808. Yes, and then we go online here, we will got the raw value right here. So this one I connected the current loop, yes, to this terminal. Yes, current loop to this terminal. So right now I will got the raw value, right? Because I series, yes, because I have only one current loop calibrator, yes. So I can series the signal, yes. So that's why this value is the same, yes. And for channel number 3 and number 4 is pair, yes. So there is no data, yeah, the terminal is pair. And for temperature sensor, right now I push the clip to 50 degrees Celsius. So it error a little bit around 53, yes, degrees Celsius. And I will go step by step and explain about how to calculate to the actual temperature here, yes. So there are 3 types in this section. The first one is convert from raw value to the actual current or actual feedback of speed motor. And the second one is how to calculate the actual sensor. If we use the terminal number 14 and 15, so we have calculate not the same this one, okay. And one more, we have PQW 800, right? So this one is analog output, so we will use unscale, yes, to set point the analog output also, okay. And then I will measure the current. If we control from the WinCC Explorer, so we can measure the current. If milliamp is vary, then the VFD or some electrical devices is vary also, okay. Good. So right now I will use scale, convert from speed feedback motor to the actual. Yes. So here go to the library tab and then go to standard library and then go to TIS event converting blocks and go down. Yes, go down to find the FC105 right here. FC105, it is convert from raw value to the actual. Okay, so drag and drop to the network and then we will got here FC105, it is scale values. So we can push F1 to see the hell. Yes, if we would like to see the formula, yeah, we can see here and we can read about how to use this function FC105. Okay, so everyone can read. Yes, from here what is the meaning of the EN, what is the meaning of IN, what is the meaning of HI underscore IM. Yes, so it very informative here. Yes. Okay, so for the in here we can read. Yes, read together. So in it is the input. Yes, input value to be scaled to read the value in the engineering unit. Okay, so it is the raw value from the analog input. So we can put okay, the feedback, right? PIW 800. So here we can put PIW 800. Okay, command will automatically, because we already remark on the symbol. Yes, we can remark from here. Yes, so it will show here and here is the high limit, right? So we can continue read. It is the upper limit in engineering unit. Okay, so it is the input also and then here is the high limit. So example, the motor is 2 poles. Yeah, so we can select with the same as the nameplate of the motor. Example 1500 RPM, so I can use here 1500.0 RPM. And for lower limit here, lower limit in engineering, so I will start from 0, so 0.0. And here is the bipolar, it is the input also. So as the signal state of 1 indicate that the input value is bipolar. Okay, so default I will use the global variable. Yeah, example M 0.0. Yes, and next go to RET underscore VAL. Yeah, so continue to read here. So it is the return value of word, right? If the instruction executes without error, see error information for values other than word. Okay, so here is the word, so I can put any memory, example MW 50. Yes, and out, the last one is out. So out is the result of the scale, right? So we would like to know this actual value. So example, I will put, it is the real, right? So I will put MD 100. Yes, MD 100. So good. Now we done for the feedback speed of the motor. Yes. And then next we will create the current of motor, right? So we can insert one more network. So actual current of motors. Okay, then we can go to FC105 again. Yes. So no need to override. So we can click no. And for the symbol of the current, right? The symbol of the current is PIW802. Yes. So here we can put PIW802. Yes. So feedback current of the motor and high current of the motor, example 250 dot current. Yes, 250 m and start from 0.0 m, and here I can use m 0.1 and MW52, and here I can use MD 104. Yes, and then we need to show the temperature, right? Temperature transmitter. Yes, we need to show the temperature of the motor. Example, we install the sensor on the bearing or the winding of the motor, so we need to show the status of the motor, how much degree Celsius. So we can use network number 3. It is show actual temperature of motor. And then here we cannot use the scale, right? We can use the formula. Yeah. First we need to convert from integer to double integer. Yes. Actually, the previous video I already explained this one for PLC S7-200 Smart. Yes. But now I explain again. Yes. So first we need to convert from integer to double integer value, because this one is integer. Yes. So I will use the block convert from integer to double integer here. Yes. And then I will convert PIW, yes, 808 here. So we can also copy and then paste here. It is the temperature of motor, right? And then here we can use the temporary variable. Yes. Example, I will use temp1, and the data type is double integer, right? Because we use double integer. Yes. So we can select double integer here. So here we can select temp1. Yes. And then we need convert from double integer to real, right? So go here. Convert from DI to real, right? DI to I. Here. So here we can use temp1, and here we need to insert one more temp, right? So example temp2, and the data type is real, so I will select real. Yes, and here we can use temp2, and then I need to divide this one by 10, right? Because it is the formula. Yes, so we need to follow the formula. So I will go to divide real, so divide real here. I will divide temp2 by 10.0, and then I will got the actual temperature from the sensor. Okay, so example this one I will use MD 100H. Yes, and not yet ready. We have one more for set point value to the VFD, right? Example, if we would like to set the speed of the motor, we can set from 0 to 50 hertz, right? And then we can go to insert one more network. This one, set point frequency of motor to VFD, right? And here we can use unscale convert. Yes, so drag and drop the unscale convert to the network. Yes, and then here we can read. Yes, by push F1 we can read the formula. Here is the formula. Yes, and here is some value. Yeah, the standard value of this formula, and we can read. Yes, and here is the example of the scale block, yeah, function. So here is the enable. If we don't enable the block not work, right? Doesn't work. And here is the real. Let's see, MD10, MD20, MD30. Yeah, it's just example. Because here is the boolean. Yes, here is the real. So real we can set from 0 to 50 hertz. Yes, of the frequency of the motor. So let's go to our network. So here I can use some memory that set point from the WinCC Explorer, right? So basically I can use MD 108 plus 4 112, right? Okay, 112. And here is the high limit. So high limit example 50.0. Yeah, it means that 50 hertz. Start from 0.0 hertz. And this one example I will use M0.2. Yes, and we can read here output is integer, and the return value, it is the word, right? So return value I can use MW54, and for the output is the result, right? The result is integer. So integer I can use some temp, right? Because we cannot put directly from this one to the PQW, right? Example, we put PQW 800, we will got error, right? Okay, so we need to convert. So it is integer, right? Here, integer. So basically we can use temp3 and data type is integer. So example temp3, and then I will move temp3 to PQW 800, right? So I will use move function and then move temp3 to PQW 800. Okay, so that's all. We have 4 items that we need to do. The first one is set value of frequency of the motor. The second one is show the feedback speed or feedback frequency. The third one is show the current of the motor, and the fourth is show the temperature of the motor. Okay, so that's all. And then we can save the project, and then we can go outside, and then we can download. Yes, go to block. Let's see here, if we put the FC 105 and 106, we will got the block generate automatically, right? And then we can select all and then download again to the CPU, select all, stop the CPU, and then restart the CPU again. Yes, and if we open to see the status here, yeah, we can online to see the status. So right now the feedback of speed motor around 373 RPM. Yes, so if I adjust the current loop, yes, adjust the current loop here. Yes, okay, let's see, the motor is 747. Yes, I select to 12 milliamp. If I select to 16 milliamp, yes, around 1124 RPM. If I select to 20 milliamp, it will show around 1498. It's nearly 1500, right? So it error a little bit. Yes, and this one show around nearly 250 M. Yes, for current motor. And for this one, we can select the RTD calibrator. Yes, right now I select to 0. Yes, if I increase, yes, right now I increase to 100 degrees Celsius. Yes, so it error 1.4 degrees Celsius. And for analog output, yes, I will show in the WinCC because we can set from the WinCC Explorer. Okay, so good. And then for the scale and unscale, we already created. So here we can remark as rank from 0 to 250 m, and this one, so the temperature example, this one unlimited, right? But we have specific also. Example 0 to 150 degrees Celsius. Yes. And then set value or set point to the VFD. So we can set from 0 to 50 Hertz. Yes. Okay. So I will decrease to the minimum. Yes. 0 RPM. Yes. And then now let's go to create the WinCC Explorer to do the page for set point and feedback right here. It is just example. So let's go to WinCC Explorer, open. And then create the new project. Yes. Go to file and then choose new. I will insert the create the single user project only for test. So example connect with PLC S7-300 and browse to find the folder that we already created on desktop. Here, create. Yes. So wait a moment for creating the project of WinCC Explorer. And first we need to create the connection, right? From the WinCC Explorer to the PLC. So basically, let's go to Take Management, right click and then open. We need to insert, right, the connection. So right click on Take Management, go to Add New Driver and choose the SIMATIC S7 protocol suite, right? If we have SIMATIC S7-1200 or 1500, we can choose here. So right now I will use S7-300. So I will use the top one. Yes. SIMATIC S7 protocol suite. And then I will use the TCP IP, right? Because I connect with the Profinet port here, 192.168.0.1. Yes. Then right click and then choose the new connection. Example PLC S7-300. Yes. And then we need to put the parameter, right? Connection parameter. So right click, connection parameter. So here is the IP address of the PLC and here is the rack number of the PLC that we would like to connect from the WinCC Explorer. So here is the slot number. Yes. So let's check here, hardware configuration. So the first one is IP address, right? So 192.168.0.1. So I will put here 192.168.0.1. Rack number is the rack number 0. Yes, it is correct. Slot number, it is slot number 2, right? CPU is slot number 2. It is slot number 1 and this is slot number 2. So the CPU is 10 slot number 2. So I will put slot number 2. Yes, that's all. And then we need to set the parameter here also. So right click here and then system parameter, go to the unit. Yeah, here is very important. Yes, so I will explain. So if we would like to use the simulation, we can use PLC sim TCP/IP. Yes, .1. It is the protocol. But right now I will use the LAN cable, right? So LAN cable is my LAN cable here. Okay, we need to go slowly because otherwise everyone don't understand about how to do, right? So the connection that I connected to the PLC with my PC is Intel 82574L, right? So here we need to choose the network. Yes, current network that we connect to. Yeah, here. So if we would like to use simulation, we can use here. If we would like to use the device, connect directly to the device, example the PLC S7-300, we can select here. Okay, good. So like this, if we would like to activate the project to see the connection, yes, I will show. We can go to activate. Yes, and then the connection will show connect. Yes. So we will go step by step for easy to understand. Let's see here. It shows the trick signal. It means that the configuration of the project of WinCC with the PLC device is okay. Yes, connection status is okay. Okay, so I will deactivate first. So next we will go to create the text, right? Because we have 4 text that we need to use. The first one is feedback speed of the motor, MD100, right? So I will write as speed motor. So it is the real, right? So floating point 32 bits, it is the real. And the address is MD100, right? And next we need to show the actual current of motor, right? So MD104. So actual current motors. So it is real also. And the address is MD104. And next we will show the actual temperature of motor, right? So MD108. So motor temperature, the same data type, MD100H, and the last one is set point frequency or set point speed of the motor, right? So MD112, so set speed motor (112), MD112. Yes, so that's all for this text. And then we need to create the screen, right, to control or to show the actual value of the speed motor, current motor, and temperature of the motor, right? So let's go to WinCC and go to graphic designer, right click, choose the new picture, yes, and then I will rename this one to be screen 1 or motor screen, yes. And first we need to set the start up with this screen, right? So let's go to computer, go to property, yes, right click, property, go to property again, go to graphic runtime, and start picture. We can browse to find the picture here, motor screen, and here is the window attributes. So I will use screw bar, status bar, adapt picture. No need to use the full screen. Yes, if everyone would like to use the full screen, we can check box here. Okay again, and then go to our graphic designer and then open the screen to design the page for see the data or set point the value to the VFD. Okay, so wait a moment for open the screen. Yes, we use only one screen. For example, if we would like to use another screen, everyone can add more. Yes, because in the previous video I already show and share about how to create some screen. Yes, okay, good. So basically, if we would like to change color, example, I would like to change some color, I cannot change, right? So we need to go to effect and then global color, set to no. We will can change the color. Yes. Example, I will use some color here. It is my background. And then I will use the rectangle for show the current, set point or speed the motor. And here we can adjust the geometry to be 500 or 800, and the height is 600 or 500. Okay, we will got like this, so no need to use this one. Yes, 450. Yes, like this. So we will got the small page like this. So here I can use some symbol, so go to this tab and then SIMATIC HMI symbol library. Yes. Okay, and then we can zoom the picture. Yes, we can zoom the picture like this. And then if we would like to change the picture, we can double click and choose some picture that we would like to change. Example, we change to be another picture. Example, another motor here. Okay, we can change this motor. Yes. And we have some parameter of the motor, right? So I will use the smart object here. Example, we use IO field. Okay, I will put like this. We can adjust later. Yes. So if we select the IO field, we will got the text, right? So this one I will use set speed motor. Yes. And choose the upon change. And here is the font size that we would like to change. Example, I change to 34 for size. And font, we can choose another font that we want. Example, Tacoma. And for the color, if we would like to use this color, we can also change. Yes. But don't forget, go to effects and then choose this one to be no. This one no also. We can change the color. Okay. So example, the background change to black color for the background. So we can double click and then change to black. Yes. So I will put like this. Okay, and for this one is set value, right? So let's go to the static text. This one should be set value, right? So set value, set speed motor. So for the font size, we can change. Effect, we can choose no. And we can go to align the text. Example, central. So maybe I will add more for geometry to be 1000. Yes. So we have set speed motor. This one we can go to style, alignment X, I will go to left, and the unit is hertz, right? So we can put the unit. For the graphic, we can design the style that we want. Yeah. And for this one, I just, for example, so we can put like the first. We can design to be better than this. Yes. And then we can duplicate. Select all, duplicate for feedback speed of the motor, right? So here, PV, process variable speed of the motor. So the unit is RPM, right? So here I will go to center. Yes. And one more is show the temperature of the motor, right? So temperature, we can duplicate. Okay, we can duplicate like this. So temperature, motor temperature. Yes. Temperature. Okay. So this one is degree Celsius. Yes, degree Celsius. And one more for show the current of the motor, right? So we can duplicate for current of the motor. So current motor, and here is M, right? So M. Okay. And we need to start and stop the motor also, right? I will create some logic, for example. So I will add button start. Okay, go to effects, change this one to no. Okay, start, and one more button for stop. Okay, like this. And then this one we can adjust a little bit like this. And then this one should be blue. This one should be red, and then I have one rectangle to show the status of the motor, and we will add the logic. Yes, so don't forget, go to effect, no, change to red. Yeah, the status normal, motor stop, it will show red. This one we can adjust to be go to font 40, maybe. Okay, yes, and we need to choose this tag, right? Because we just put only one for set speed. For feedback speed, we can go to configuration dialog and choose the tag for PV speed of the motor, right? So speed motor here. Okay, and this one also motor temperature, right? So choose the correct tag with motor temperature, and for this one is motor current, right? So motor current. Okay, so that's all, and then I will create example logic, yes, to start and stop the motor. So we can go to OB1. Okay, I will outline first, just example. So start and stop motor command. Yes, basically we have stop, start, and output, right? So here I will use output. So let's check the output address, digital output. Sorry, this one unlock. Oh, sorry, this digital, right? So address it will start from Q136.0. Okay, so Q136.0, it is motor 1 drive, and I have M10.0, M10.1, and hold signal by Q136.0. So this one example stop motor 1, this one start motor 1. Yes, and then we can save, download, can online. Yes, and we can go to the text management. Yes, so start stop M1, start M1, motor 1, and it is the binary text, right? And start from M0, M10.0, M10.1, Q136.0, right? Okay, good. And then we can go to our WinCC screen. Yes, So the start button, we can go to the events, go to mouse, and if I press, I will set to 1, yes, of the take start, right? And if I release, I will set to 0 and take start, right? It is basically because I already show and share in the previous video. The stop also go to events, mouse, and then go to direct connection. I will set to 1 when I press, and when I delete first this one, press, I will set to 1 with the take stop motor 1, and I will reset to 0 when I release. And then I need to show the status of the motor when running, right? I will change color to be blue. So go to property, go to color, and then go to background. Go to dynamic dialog, and then choose the take motor 1, and choose boolean. And then when true, I will change to green. I will change this one to upon change, yes, to green immediately. And then we can save the screen. So that's all. And then we can simulation, yes, don't forget save. And then we can go to WinCC and then activate the project. And then I will show the status of the PLC also, yes. Okay, let's see here. It is just example for the screen. We can design to be better than me, yes. So example, I start the motor, yes. The output is turned on also for the motor, for the PLC, yes. I stop, I start, yes. And we need to see the current and speed, right, of the motor. So the first one, we can set point the speed, yes. I will show the multimeter when we set point the speed. Let's see right now the speed set point to VFD is 4 milliamp, right? So example, I will set to 50 hertz. We will got 20 milliamp, right? Example 25 hertz. We will got 12 milliamp, yes. And the speed of the motor PV, I will parallel with the current loop, right? So I will adjust. let's see, 20 milliamp. Yes, so it will show around 1499, nearly 1500, right? And we adjust to 12 milliamp, it will show around 748. Yes, and the temperature show around 28, and we adjust the RTD calibrator. Yes, 50 degrees Celsius, 100 degrees Celsius. Yes, so it shows perfectly. And here the start button. If I stop, yeah, the output is stop. If I start again, the output is start. Stop again. Yes, so it works perfectly. Yes. So this is just an example about how to link the WinCC Explorer SCADA to the PLC S7-300. Yes, by using the step 7 microwin SIMATIC Manager. Yes, to create the example project and WinCC Explorer. Okay. So for the skin, everyone can design better than me. Yes, I just example. If we got the value like this, we can design the style. It is pre-style. Follow the everyone design. Okay. So for this video, I would like to conclude. Yes, I think everyone can do it because we use the library of SIMATIC Manager. Yes, if we install the software, we can got this library, and then we can drag and drop to you. Follow the instruction by press F1, and then we can read. Yes. So thank you very much for watching my video. If everyone have any more question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.